Yeah, now we come to this question. It says that using the ground as the reference, which is zero position, sketch a position time graph for the entire motion of the stone. Okay, to take you back, this is what we have. The stone was projected from the top of the tower. It reached maximum height, then dropped, passing the point of projection, and struck the ground. So they want us to sketch the position time graph for that motion. Yeah, so having this as our axis, then we need to know, they said it's supposed to be a position time graph. So on the y-axis, we have the position in meters. And on the x-axis, we have time in seconds. So this is what we are having. And we are sketching position time graph. So we need to know that our projection took place from a height of 50 meters. So remember they said we are having the ground as reference, implying that our ground is zero, is where we start our measurement from. So which means that if this is our zero, we go up to 50. And that's going to be our point of projection. So we indicate it as 50 meters. So what do? We have the trajectory. The stone went upwards, reached maximum height, and came down. And we draw that. So it went like this, like that, and came down. So we can go ahead and even indicate maximum height from the point of projection. Remember, we found it as 5.10. But remember, we are using this one as our starting point. So if this is 50, if you add 5.10, what do you have? This point is going to be 55.10 meters. You can even go ahead and indicate the time taken to reach maximum height. We did it. We found that one already. It was 1.02 seconds. Yeah, now we come to this question. It says that on its way down, the stone takes 0.1 seconds to pass a window of length 1.5 meters. As it is shown in the diagram. Then they say calculate the distance y from the top of the window to the ground. So we can see it here. This is our window. It is slightly below the top platform of the tower. And they want us to determine the length from the top of the window to the ground. But they have told us that the stone, when it was moving downwards, it took 0.1 seconds to cover this length of 1.5 meters. So with that data, how do we go ahead? So this is what you have to know, that the information given is only for this window. So this is the part we are going to look at first. We forget about the rest. We are going to look at only window length. Okay. And what do we know about the window length? We know its length. We know its length. The length of the window is 1.5 meters. Okay, what else do we know? We know the time taken to cover the window, which is 0.1 seconds. Okay, but we know something else. It's a projectile. So we know the G. The stone is moving downwards this time around. So our G is positive 9.8 meters per second squared. Okay, with this information, what else can we determine? So we can determine VI. Yes. What is VI? VI is the initial velocity when the stone was here. So with this data, we go ahead and look for the right equation. So the right equation here is going to be, the third equation of motion, which is delta x, giving us VI delta t plus a half a delta t squared, because it's the one which satisfies this information. So next, what do? We substitute. Delta x, we know it's 1.5. And VI is wanted, but we know the time, which is 0.1 plus half times acceleration, which is 9.8 times 0.1 squared. Yeah, this is what we have. Then from here, what do we get? Yeah, so this is what we get. Yeah, so at this stage, what we do? We proceed, we collect like terms. We take this one, that side, and because it's positive this side, it becomes a negative. Yeah, so this is what we get. And from here, we go ahead and get VI by dividing both sides by 0.1. So we have here 1.451 divided by 0.1, giving us 0.1 VI over 0.1. So you have your VI as, so you have your VI. But you need to know that the initial velocity we have just obtained is the velocity at the level of the window, at the top of the window. So this is what you have to imagine, that when the stone was projected, it went up and passed here. So as it was passing here, the top of the window, its velocity is 14.51 meters per second. So from there, what do? We can use this trajectory to determine this displacement from the top of the tower to the top of the window. Once we have this displacement, we can now determine y. Why? Because we know from here up the top of the window is 50. So if you know this one, you're just going to subtract and get the y. So with this in mind, what do? We take the information. This is what you have to know about the information. We know VI of the stone, which is 10 meters per second. Okay. What else do we know about this trajectory? We know, okay, we are looking for displacement. Okay. And because the stone was initially projected upwards, we know our G, which is negative 9.8 meters per second squared. And what else do we know? We know the final velocity. What was our initial velocity in this section is now going to be our final velocity for this trajectory. And what is it? It is 14.51 meters per second. So with this information, what do? We substitute. What is the best equation for this data? The equation is going to be VF squared equals to VI squared plus 2A delta X, which some people call second equation of motion. So what do? We substitute. VF is known, is 14.51. But here we need to know that doesn't make a difference. That because the stone was going downwards, this was negative, so you can use it here. Yeah, but because it's going to go into squaring, it will not affect the answer even if you have positive. So what is VI? VI is 10 squared plus 2 times negative 9.8 times our displacement, which we are looking for. Yeah, so this is where we are. So what do? We collect like terms. We take this side because they are like. So you're going to have 210.51 minus 100, giving us a negative 19.6 delta X. Yeah, so we reach this stage, and what do? We proceed and get delta X by dividing both sides by negative 19.6. So at this level, what do? We get our delta X as negative 5.64 meters. Now, you need to know that from our sketch here, now we know that this displacement is 5.64. But we know that from the entire length of the tower is 50. So from here, what is our y? You have to know that from here, we know that 5.64 plus y gives us 50. Yeah, that's what we see here. This is 5.64, this is y. When you add them together, you get 50. So from there, we can get y. And our y is going to be equal to 50 minus 5.64, giving us this 44.36 meters. So that is the length y. So from there, see you next time. Stay with us. Don't forget to subscribe. Bye-bye.